Alright, hello, this is Miss Goodwin, and today we are covering objective 2.2.1 Triangles and the Angle Sum Theorem. The objective for today is that we can prove the Angle Sum Theorem and use it to find the sum of interior angles of any polygon. So this is going to be another two-parter because it has a lot of information. So go ahead, watch this video, take a little break, and then watch the next one. So first we need to define some terms regarding triangles. So there are two ways we can describe our triangles. The first is using their sides, and the next is using their angles. So our first kind of triangle is a scalene triangle. This means that all three sides are different lengths. Okay. An isosceles triangle has at least two sides that are the same length. Okay. An equilateral triangle, all three sides are the same length. Okay. So those are how we classify triangles using their sides. Now we look at the angles. So an acute triangle, all three angles are less than 90 degrees. So all three triangles will be less than 90 degrees. A right triangle has one angle that is exactly 90 degrees. And usually it'll look something like this with a little square in the corner, usually. Okay. And now an obtuse triangle has one angle that is greater than 90 degrees. Now let's look at how we can combine these and make a little table. So remember, scalene triangle is all three sides are different. An isosceles triangle has two sides that are the same, and an equilateral triangle has all three sides are equal. An acute triangle has all three angles are less than 90 degrees. Right triangle has one angle that is exactly 90, and an obtuse triangle has one angle that is greater than 90. Now, an important thing to know is that a triangle will always have two acute angles at least, but it's whether or not one of them is a right or a scalene, or right or obtuse angle that determines whether it's a right or obtuse triangle. So we can go ahead and combine these. So like a scalene triangle that's acute, all three sides can be different and all three angles can be less than 90. So if we look here, all of these angles are less than 90 and all three sides are different. An isosceles acute triangle will look something like this. Okay. So these two sides will be equal. It also means these two angles are equal as well. Now, equilateral triangle, that is also an acute triangle, will look something like this. It's a little hard to draw an equilateral freehand, but all three sides are going to be equal, and all three angles will be equal. I should probably clarify here that not all three angles are equal. None of them are equal in the scalene acute. So those are all acute triangles for each of the different side combinations. Now, a right triangle has one angle that is equal to 90. So it typically looks something like this. Oops. That's a little better. So this is a right angle. We don't know what these two angles are, and all three sides are different. We can also have a right isosceles triangle, which again, because it's freehand, does look very similar, but these two sides are equal and these two angles are equal. Now, we cannot have a right equilateral triangle because that would imply all three angles are 90 degrees, which is frankly not possible with a triangle. So let's look at our last row, obtuse triangles. Now, an obtuse scalene will look something like this. Okay. So this is a scalene triangle and is also obtuse. So this angle right here is going to be greater than 90. Whereas these two are some other length. Or some other degree. And all three sides are different. Didn't really need to put that, but it's fine. Now an obtuse isosceles triangle may look kind of similar, but these two sides and these angles are congruent, but we still have the one obtuse angle in the middle. And then we cannot have an equilateral obtuse triangle because, again, we can only have one angle greater than 90. We cannot have all three angles greater than 90. So let's move on to the next page. Ooh, so now we're going to be proving something. So let's ask ourselves, what do all the angles in a triangle add up to? Think about it for a moment. Jot your answer in your notes. And now let's look at our proof. So I've gone ahead and drawn this line DE. And it is parallel to the line BC right here. Oops. My bad. So that is given to us. We know lines DE and BC are parallel. So that will be the first reason of our proof. Our second statement is that angle P right here, angle A, which is this one right here, and angle Q right here, notice they form a straight line. That means if you add them together, they will equal 180. This is known as the supplement angle theorem. Okay. So all three angles add up to 180. Now, if we notice here, think back to the first section. We can see that angle Q and angle C are alternate interior angles. Which means they are congruent. In the same vein, we can see here that angle P and angle B are also congruent. Because of their alternate interior angles. So since Q equals C and P equals B, we can substitute P for B and C for Q. That should be capital B. And we can see that angles A, B, and C added together give you 180 because we substituted those in for P and Q. Oops. Okay. So that is our proof for what we call the Angle Sum Theorem, which says that all interior angles in a triangle add up to 180 degrees. Now, real quick, we're going to use these as an example, do a couple of examples where we use the Angle Sum Theorem to find missing angles in triangles. So the first example, we are given a triangle where one angle is 68 degrees, one angle is 47, and our last one is x, and we want to find x. So let's say this is angle A, B, C. We know A plus B plus C equals 180. Substitute in 68 plus 47 plus x equals 180. 68 plus 47 gives us 115 plus x equals 180. Subtract 115 from both sides. X equals 65. So we know our missing angle is 65 degrees. Now let's look at a more difficult example. We still want to find x. So we can see 6x, 4x, and 2x. We could do the exact same process. So we have 6x plus 4x plus 2x equals 180. Add those together, we get 12x equals 180. Divide both sides by 12. We get x equals 15. Which you can do in a calculator if you don't believe me. And then you can plug 15 in for x to get any angle. So we get 4 times 15, which gives us 60. 6 times 15, which gives us 90. And 2 times 15, which gives us 30 degrees. And that's it. So go ahead, summarize. How can we use the Angle Sum Theorem to find missing angles in a triangle? I will see you around in the next video. Bye-bye.